Packages in PL/SQL. A package is a concept whereby one can place multiple functions and/or procedures into a single chunk of code. There are certain advantages. The first one is in terms of advantages in tuning. A database administrator can actually take a package and pin it into memory. All this means is that the package will not be parsed and compiled every time it's executed. Packaged code is self-contained within applications. Obviously that depends on how you package your procedures. In other words, what procedures and functions go into which packages. Obviously the code is better organized because you can split between applications, you can split between different types of functionality. A package has a name, so therefore it's stored permanently in the database. Being stored permanently in the database is obviously having the advantage that it can be re-executed with ease from anywhere. Packages have a very specific structure. A package is divided into a definition section and a body section. These are two distinct pieces of code. We'll see an example in a minute. The body can't exist without the definition, unless the body has absolutely nothing in it. The definition defines procedures and functions and potentially global variables, and the package body contains the actual code for those procedures and functions. Here's the create package definition syntax. The definition, remember, is not the same as the body. The definition simply contains procedure, function definitions, and potentially global variables. What I mean by global variables are variables which are global to the package. They are not accessible from outside the package. Most programmers understand variable scope. Variable scope means that a variable is available within a certain structure or within a certain block of code. In the case of PL/SQL, between a begin-end statement. In the case of a global package variable, that variable is available to any function compiled within the body of the package. Once again, create, the or replace option will allow recompilation and replacement with new code of a package already existing in the database. Again, the data types are more general than in normal SQL. The package definition contains simply procedure and/or function definitions. What I mean by definition is that it will simply say procedure, list all the parameters and their data types, plus any return values. That's what the definition is. Very simple. We create package body syntax. The package body is the part where all the actual real live code for all the functions and procedures as defined in the definition section are actually created and coded. Again, the syntax for creating or replacing is exactly the same, except that you now have the keyword body in there. Again, you can have global variables, and they have the standard PL/SQL data types. Note that parameter data types in PL/SQL are the restricted data types, not data types declared within PL/SQL itself. You can declare varchar2s with a data length inside a PL/SQL stored procedure. The restricted data types only apply to parameters. Within the package body, we have specific procedures and functions, and this is the syntax. It simply says procedure or function lists the parameters is as, and then the PL/SQL code is contained between the begin and end statements. The alter package command is very similar to the alter commands for both procedures and functions, other than the fact that you have the option of compiling the whole package, including definition and body, or just the specification, which is what I call the definition, or the body only excluding the definition. The drop package syntax is just the same. You simply say drop package and then the package name. Let's go and take a look at some examples. Here I have a very simple example of a package called utils, utilities, which I created containing a divide function, a percentage function, and a suppress zeros function. This is the definition. This is the body. Let's go and create the definition and compile it. And that compiles fine. Now let's look at the functions. All this does is a somewhat slightly more complicated version of division, in that if the denominator, which is the number underneath the division sign, is 0, we return a 0 as a result of the division. As you know, any number divided by 0 actually gives you an undefined result. A computer will give you the same result as well. Dividing by 0 usually results in horrible errors on computers, so you want to be very careful not to do it. Percentage function simply uses the divide function to divide the numerator by the denominator, multiplies it up by 100, rounds it to 0. If the result is 0, it returns null, otherwise it returns a character format version of that percentage figure. This formatting will output a number of 0% as 0% with both characters in it. If an exception is thrown here or here, it will simply return 0 as well. The suppress zeros function will simply ask a number if it's 0 and suppress the zeros by simply returning a null value. Very simple. Let's copy and paste the package body, create it, and compile it with the alter package command. And everything seems to be okay there. Now let's simply run some examples. So I'll just copy and paste all these examples. One point to note, the package is called utilities. A procedure inside that package happens to be called divide. The way to access that procedure is by referencing it as package name dot procedure or function name. As you can see, all these are the same. If I was to execute a procedure such as divide from the function percentage, which happens to be in the same package, I do not need the package dot prefix, since we are in the same package. So once again, let's copy and paste these examples and run them.